Our next presenter is Raja Iqbal. He's CEO and founder and chief data scientist at a company called Data Science Dojo. He's formerly from a couple of other little companies called Microsoft and Stanford. You may have heard of them. The term that he chose is data scientist to kind of put that practitioner spin on it. Please welcome Raja.
Can all of you hear me? So the term that actually, there was a confusion. I chose the term an educator, right? So, and maybe I do data science, but I consider myself as an educator at heart. So another talk on large language models and generative AI. It's almost the end of the conference, and we are still talking about LLMs, right? So the context of the talk is, I'm going to actually talk about my view of large language models as a practitioner. I've been building applications. Not myself, I do the talking. I mean, my team actually does all the work. I mean, you know, I talk, right? So, but I do understand things. So basically what we will do here is, we'll look at how do you use a foundation model like ChatGPT or Llama 2 or any other Anthropic and so on. How do you use these models to create an LLM application? So that's the idea. So we'll start with this. Let's get started. Okay, this is the clicker. This is, okay. Okay, this works. So what I'm going to do here is, I will start with the common design patterns. What are the common design patterns that you use to build LLM applications? Then we'll talk about some of the key challenges that you're going to face. And then if we have time, we'll take questions. Finishing all of this, or maybe providing coverage to all of this within 20 minutes, it may not be easy. The slides are going to be available somewhere on the conference website. Let's see how we actually go here. So, how do you build a custom application? So first thing that all of us know is we are using ChatGPT. We start with some model by OpenAI, GPT-3, GPT 3.5, or maybe GPT-4, maybe PaLM 2 by Google. We may start with Llama 2 if we are interested in open source. Well, I use these models, but these models have been trained on public data. What about my tickets? What about my support tickets? What about my sales proposals or my invoices and the emails that I've sent out to my customers? How do I get information on those? So that is the idea. So broadly speaking, you can have, very broadly, you can have three different approaches. You can actually train a model from scratch. So that's the first approach that you can take. Well, we'll talk about it. Then another approach is fine-tuning. You take a foundation model, fine-tune it. And the third one is what we call in-context learning. Let's look at these one by one. So when we are training a model from scratch, let's say there was no GPT 3.5, or there was no PaLM 2 or Llama 2. I take all of my documents and I train the model from scratch. The problem with this approach is this is computationally very expensive. We don't have that much data, and it's computationally not feasible. From a cost perspective, this is not feasible. Most companies would not actually be able to do it. Okay, and that's why there is this concern around certain companies actually having a monopoly over this whole space. The next approach is, you take a foundation model and convert it, or maybe fine-tune it, and use it with your own data. So you learn the language, or the language capabilities are still coming from GPT-5 or GPT-4 or GPT 3.5, whatever that is, or Llama 2, or any of the available commercial models, commercial foundation models, or open source models. You start with those, take those, and augment them with your own custom data. So that's the second approach. Definitely, cost goes down, GPT 3.5 actually launched maybe 2 weeks ago. OpenAI released GPT 3.5 fine-tuning, and that was actually a big piece of news because, well, people were excited about it. The third approach is what we call in-context learning. What is in-context learning? If you look at this, we have, I wish I can point to this. Let's see. If you look at this here, right? So we have this foundation model. I'm going to use the foundation model as is. Exactly the same foundation model. I'm going to use it. And then I'm going to augment that foundation model, not by retraining it. I will use that foundation model as a black box. I'm going to take my documents, my entire repository of documents. I have 10,000 insurance proposals. I have 10,000 support tickets, whatever that may be. I'm going to actually chunk them, break them down, store them in a vector database, and there were some talks around vector databases, create some embeddings, put them in a vector database, and at the time of inference being when someone decides to actually come in and ask questions about those proposals, those invoices, those emails, when that query is entered, first there is a semantic search. The previous talk was actually talking about semantic search, right? So you semantically pull relevant documents, or in this case, relevant tickets, or maybe relevant insurance proposals. Whatever is related, you have a prompt component, you pull those relevant documents, combine them, and send them to the foundation model. So it's a clever hack. If you look at this, I love this approach because you have almost reduced your inference problem from a machine learning or AI problem or a deep learning problem to a data engineering problem. This is data engineering. So someone was asking me, hey, I mean, this is fascinating. I mean, a lot of deep learning. No, I mean, no deep learning here, right? So because someone else has done the heavy lifting, this is a data engineering problem if you look at it. I mean, maybe a bit of exaggeration here, but 95% of this is data engineering, right? So you're using a vector database. You have, you're chunking the documents and all of that. So it's your classic software engineering, okay? So if you look at this, I'm not sure how visible this is from far back. I will do my best. So this is an adapted version from A16Z blog, and I've modified this a little bit. If you look at this, when you deploy a system in production, it is non-trivial. It is not going to be something, hey, I will just use ChatGPT and things are going to fall in place. There are some serious challenges that are going to happen, right? So if you see under, let's say, orchestration, right? So within orchestration, you will see different tools. LangChain is there, fairly popular tool. Llama Index is there, then ZenML is there. So there is a few tools in there. So what does orchestration help with? Orchestration actually helps you with, you have different types of data. You have input data, you have JSON data, you have Excel data, and your data is sitting in a CRM system. It is sitting in a SQL server. You want the output to be in a certain format. You want, your data is too big to fit in a single context window. You have to chunk the data. So all of those things, some of these tools, they actually help you with orchestrating the entire thing. And some people, I had a discussion with a friend who actually is running another startup. So he was saying, no, I don't think that LangChain is an orchestration tool. So, if that is, whatever, depends upon what your definition of orchestration tool is. I will let you decide. But definitely it makes life easier. Once you have built the app, you have to deploy the app. So if you see under output, there is frameworks, or there is platforms like Streamlit and a few others, right? So you can deploy the app. Then when you're talking about LLM ops, just like ML ops or DevOps or DevSecOps, there is a concept of LLM ops. What is LLM ops? Observing your model, what we call observability. Can I make sure that that the prompts that are coming in, can I monitor the prompts? The responses, are the responses okay or not? How many prompts were toxic? How do I track the versioning of prompts? My prompt yesterday was something different. I modified the prompt. Is it different now or not? and so on. Just like ML ops, there is this concept of LLM ops, and I wish I could go into more detail. Then there is, I think one interesting thing would be in here that is worth talking about. First, vector databases. A vector database, what is a vector database? Well, you create embeddings. Your computers don't understand text, right? So, I mean, you have to convert them to numbers. So there is this idea of embeddings, and you create these, you create this numeric representation of your documents. You store them in vector databases. And the great thing about vector databases is if your embeddings, they are obtained semantically, when you run a query, and let's say if someone ran a query, she is the queen of the Netherlands, and then this is the prince of Amsterdam, right? I'm making it up, right? So now both are lexically keyword-based. They are not related, but lexically they are related, right? So vector databases, they make this semantic search easier. And then, of course, like your traditional SQL or relational databases, there is this concept of indexing. How do you index them and all of that? So there is this whole ecosystem around that. And there are some players you can see. Pinecone is here, Redis is here, and there is a few other players in that space as well. Then there is this concept of semantic cache or LLM cache. If I'm issuing, just like caching in or a CDN or a browser cache or a disk cache or a mem cache, how do you make sure that the prompts that have been, or the queries that have been previously responded to, if another query comes in that is semantically similar, why should I go and spend money on inference again? So Redis offers LLM cache. Redis has semantic cache, and there is a few other players as well. I won't spend too much time on this. So while building all of this, while building these systems, here is some of the problems that you are going to run into. We have run into almost all of these problems. In no particular order, depends upon your application. For some applications, one aspect may be important or may be critical to your business. In other applications, other may be important. So the first one, we all know. The way these models improve is reinforcement learning with human feedback, right? So if the result is good or not good, if it is acceptable or not acceptable, an email is spam or not spam, if a search result is the best result or not. So think of it this way. So the idea is that you are going to align your behavior with your values or with your needs. But the problem is, how do you define values? Because something that I consider okay, someone else may not consider okay. I mean, I worked for Bing for good 5-6 years. And we would actually, within the same team, we would disagree on the label. No, this is not the best result. No, this is the best result. Few places separated. So even as an engineer working on Bing team, we did not agree on the labeling of the results. How do you decide? Anyone remembers this bot from Microsoft? Anyone? Tay? Anyone remember Tay? Okay, some of you, yeah. What happened, right? This bot was Microsoft released this bot March 23rd, 2016. They had to shut it down within 16 or 17 hours. Why? Because the bot was learning from people. And people figured it out. And guess what they started doing? They started interacting in a way that the bot started learning. Very impressionable, right? So, I mean, just whatever they're teaching me, yeah, I mean, I'm hanging out with bad kids on the block, right? So, yeah, I'm going to start doing drugs, right? So, but I mean, very quickly, within a few hours, it started saying things that it should not be saying on Twitter. It became a PR disaster. They shut it down. And you would be surprised. I mean, I don't know how many of you have tried. ChatGPT would refuse, and I will talk about that idea of prompt jacking and all of that. But it is very easy to actually deceive these systems into doing things that they should not be doing. Okay? The data sets are complex, right? So this is not the technology limitation, this is the domain problem, and we keep talking about this. I mean, the whole idea around the quality, the quantity of data, the duplicates there, right? So PII, right? So let's say we have some information. I built a chatbot for HR, right? And accidentally someone uploaded something. And someone figured out and yes, I mean, when we did the prompt engineering, we told the bot not to respond in a certain manner, right? So, but someone was able to convince the bot to say things that, once again, reveal information, any PII, that it should not be revealing, right? Human language is complex, right? So that's another challenge. Human language is very complex. If you look at this, so this person is being sarcastic, actually saying, hey, thank you, that airline, right? So you sent my bags here and flew me here, right? So, and the chatbot actually from that airline says, thank you. Glad to hear that, right? So, now someone might say that, yeah, I mean, let's take a bigger context window. Yeah, awesome, right? But keep in mind, if someone tells you that, if you're going to take a bigger context window, the results are going to be better, that's not the case. Bigger context window, different models are there. Anthropic has, I think, 100K token limit versus GPT 3.5 or GPT-4 has 32K, right? But bigger window does not mean better results. Bigger window just means computationally, well, it is going to be able to handle that many tokens, okay? Then there is an aspect of training cost. Training is expensive, very expensive. Then there is inference cost. Either you pay upfront on training, push all the documents and train once, or if you're using in-context learning, use the foundation model and pay it in terms of inference cost. And if you look at this, 1,500 pages for an enterprise setting, yeah, not a big deal. Single query, $20 if you use DaVinci. Versus if you use the fastest model, which is Ada, it will cost you like 40 cents, I guess, right? So if you look at this, know what your use case is. Do not actually go and chase, I'm going to use the best model, right? So, because sometimes latency matters, sometimes cost matters. Then after that, and this slide actually shows you, in some cases, you should be actually talking about latency. In some cases, you're worried about cost. Prompts are brittle. If a small variation in prompt, and by the way, no variation in prompt can actually give you different results. Same prompt, different results. This is by design. This is how LLMs work, and this is how it is. There is this whole idea of around prompt injection or risks around prompting. If you look at this, there is prompt injection, prompt leaking, jailbreaking. You are making your model say things or reveal things that it should not be saying. Then there is this problem of explainability, right? So now when you build an app, okay, so this is telling me this happened. Can you point me to the document where it is getting its information from? Because, I mean, many applications might be require more factual information. So can you tell me? So there is this idea of explainability. Can I find out where this information is coming from? Also by design, anything that is so random, there is going to be some reproducibility challenges, right? So if you want to design an experiment on 500,000 documents, 500,000 enterprise documents, how are you going to actually reproduce? Because there is so much randomness at play here. Okay, I made it, right? So last 1 minute for questions. Maybe one of you, yeah, please go ahead. Yes, I can hear you.
After listening to a few of the conference talks, everybody is talking about either fine-tuning the LLM or using context learning or retrieval augmented generation. How about, can we use both of them one after other, like fine tuning and then retrieval augmented generation? And also like few shot prompting improves the performance of LLM as well. So how about using all three of them to build a very good performing LLM? Is that even possible, just out of curiosity?
So I can pretend to understand what you're asking, right? So the problem is real world scenarios, they are quite complex. Can you use both? Sure, but my first reaction would be is why would you do it, right? So why would you do it, right? So because it is you're basically dealing with you're handling two things that are complex, right? So maybe your application may require this. Maybe you have a cascaded large language model. In theory, yes. I mean, it may be needed. In practice, this is what I recommend to my team. Keep it simple. Make it easy for yourself, right? So I mean, because can I use a random forest and a neural network and a logistic regression and naive Bayes? Yes, I can. Do I need to? I don't think so, right? So honestly, I mean, unless I know exactly what your scenario is, I will not be in a position to give you an answer.
I'll discuss it with you later, maybe.
Oh, yes, absolutely. Yes, I will be around, so.
Awesome. Yeah, and we are out of time, so we're going to have to pull the cane.
Thank you,
Sorry
everyone.
about that.